we want to look at the next data structure in R, which is matrix. Now, a matrix is a two-dimensional array that organizes data in rows and columns. Okay, you could picture a matrix as a table, a simple table. Okay, or you could also liken it to that of a data frame. Okay, so matrices are no different from data frames. Okay, the same principle that guides a data frame or data frames is the same principle that also guides matrices to an extent. Okay, so in data frames, for instance, we saw that if we want to use vectors, okay, to construct a data frame, the vectors must be of the same length. The same thing applies for matrices. If you have 2 or 3 vectors and you want to affix them, or you want to cohere them or knit them into a matrix, they must be of the same length as well. Okay, now the key difference between a matrix and a data frame has to do with how data is being stored in those two structures. Okay, so for data frames, for instance, you could have a vector whose data type is numeric, and you could have another vector whose data type is character. Okay, but when you knit them together, they stay as they are. Okay, they are independent of each other. But for matrix, if you have a vector whose data type is numeric and a vector whose data type is character, and you try to fuse them together to form a matrix, you would encounter a problem because they will be knitted or coerced into just one data type. So let's dive into the tutorials, and then you would have a deeper understanding of whatever I just said. Okay, so the first thing I would like to do is to create an empty matrix. Now, to create an empty matrix, you would use the function called matrix. So if you take note, I have an object called empty matrix, and that object called empty matrix will be storing, or will store the empty matrix I'm trying to create. Okay, so the object name is empty matrix, and since I'm creating an empty matrix, I'll say matrix, call the function matrix, hit the tab key, and since the 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 objective is to create an empty matrix, okay, the data argument will be ignored and we'll rather consider the number of rows. Let's say we want to create an empty matrix with 10 number of rows and 5 number of columns. Okay, so our empty matrix has been created. If we call empty matrix and we run, okay, you could see that we have 10 columns. We have 10 columns, sorry, 10 rows, 5 columns. 10 rows, 5 columns, just like we specified. A number of rows to be 10, number of columns to be 5. Good. Now, we would like to create matrix from vectors. Okay, we like to create matrix from vectors. So we have our first vector, which is vec, our second vector, which is vec1, and then our next vector, which is vec3. Okay, so we'll be creating two matrices over here. The first matrix is going to be a fusion between vec and vec1. Okay, just to demonstrate something to you. And then the next one is going to be vec and vec3. Okay, so let's create our first matrix. So I'll call that object matrix 1. Okay, and we're going to use vec and vec1 first. So we call the matrix function, and the data, okay, we concatenate vec and vec1. Okay, and we set the number of rows to 6, because the length of, like I said, the length of the vectors must be equal. Okay, so the number of rows is 6, and the number of columns will be 2, since we are just dealing with two vectors. Okay, so I'll run this. So now when I run this and I call matrix 1, observe the console, you will see that our matrix 1 has been created. Okay, in matrix 1 we have the first column. Okay, to we have the first column bearing vec, the vec, okay, objects, element, and then the second column bearing the vec1 object elements. Okay, but you would notice that both vec1 and vec2 has been coerced as characters. Do you see that? So you have, though you know that column 1 initially was a numeric data type, over here it has been coerced as a character data type. Okay, so in matrix you need to make sure that the vectors you are trying to put across will always be of the same data type, except you know what you are trying to do. Okay, in as much as this deficiency is in matrix, for data frames it's not. We could store different data types and we wouldn't have any problem. They are independent of each other. All right, so now let's create the second matrix. So matrix, I'll call that matrix 2. So matrix function, for the data we're going to concatenate vec and vec3. Okay, and the number of row we're going to set it to 6, which is the length of it, and the number of columns, sorry, is going to be 2. So if we should call matrix 2 and we run, you would see that our matrix 2 has been created. Since they are both numeric, we have no codes here. We want to sequence numbers 1 to 32, okay, by a difference of 2. So first we'll need to create an object to store those numbers. So I'll say secnum is my object name, and we're going to use the sequence function, that is sec function. Okay, and what we're going to do is that we're going to sequence from 1, okay, through to 32 by a difference of 2, just like I said. So we run and our sequence numbers have been performed. So we ran this and you could see, okay, sequence 1 to 32 by a difference of 2. Okay, so 1, 3, 5, blah 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 to 31. Okay, so if we should find the length of this, says the length is 16. Okay, good. So now let's create a matrix to store this data, the secnum data. Okay, that is from 1 to 32 by a difference of 2. Okay, so to do that, we're going to call, or we're going to give a name to the matrix. Okay, so we'll say let's say matrix test. So matrix test, and then we call the matrix function. Okay, so the data we're going to set it as secnum. Okay, remember we're trying to use secnum's data to construct a matrix, so we need to set the data argument to secnum. Now the number of row, we're going to set the number of rows to, let's say, 4. Okay, and the number of columns, we'd like to set it to 4 as well. Okay, so 4 by 4 is 16, which fits the dimensions we are looking at, or the length we are considering. Okay, now the argument I'm trying to explain here, the argument I'm trying to explain here is the by row argument. Okay, so you could decide to fill the matrix okay, by row. Using the data you have, you could fill the matrix by row, or you could fill it by column. So assuming we want to fill secnum by row in the matrix, okay, we enter the argument by row and we set it to true. We run this and we call matrix test. You would see that, okay, in this sequence 1 2 3 4 5 6 7 8 9, sorry, 1, you would see that 1 3 5 7 9 11 blah blah blah, okay, has been organized by row. So it goes 1 3 5 7 9 11 13 15 17 19 21 23, and then 25 27 29 31. Okay, so what if we do not want to set it by row, but we want to set it by column? Okay, so the same thing. So we create a matrix called create a matrix called matrix test 2. Okay, and we're basically going to do the same thing here. So just let me just copy this, paste it here, but in this case the by row argument will be set to false. Okay, so when we run this and we call matrix test 2, you see that now it has been ranged by column. Okay, so the first one went by row, that is 1 3 5 7 in that order. Now here it goes 1 3 5 7 in a column wise order. Okay, all right, so the next thing is how to access elements in a matrix. So assuming we want to um, pick out, let's say, value 19 from this matrix, we need to first trace where um, this particular element is located. So it's located at column 3, okay, row 2. Okay, so we'll just call the matrix the parent matrix, so matrix test 2 for instance, and then we call out column, you said it's at column 3 and row 2. So first uh, argument to fill here is going to be row 2, and then the next one is column 3. So when we run this, okay, in the console you see we've extracted 19. If we want to extract, let's say, 31 or 21 from this matrix, it is at it's on row 3 column 3. Okay, so we go here, matrix test 2, okay, row 3 comma column 3. Okay, and once we run, we have our 21 there. Good. So supposing we want to extract an entire row or an entire column from a matrix, okay, to do that, you would have to fill the row option and ignore the column option. And if it is the entire column you want to subset, you have to fill the column section and ignore the row section. So what I'm trying to say is this: assuming I want to subset the entire row, okay, a particular row, I'm going to say matrix test. We're still using matrix test 2 for instance. So matrix test 2, and then I would like to extract the entire row, so row 1 comma, leaving the column option blank. Now when I run this, you would see that the entire row 1 has been pulled out. If I want to extract row 2, okay, I could change this to row 2, and the entire row 2 has been pulled out. Alright, so for column, it takes the same shape, just that we would have to ignore the row option. Okay, so instead of we having or instead of we putting something at the row column or the row option, we'll leave it blank, and at the column we'll state the column we want to pull out. Okay, so I'll say column 3, and once we run, the entire column 3 has been pulled out. All right, now we'd like to perform some petty functions in a matrix. That is, we'd like to perform an addition, a subtraction, and a multiplication of matrix. Okay, now to perform additions of, we want to use matrix test 2 plus matrix test. Okay, so when we add, this is what we have. All right, so this is for addition. Okay, and what if we want to subtract? So we want to subtract matrix, we want to subtract matrix test 2 or matrix test from matrix test 2, and when you subtract matrix test from matrix test 2, this is what you get. Okay, what if we want to multiply matrix test 2 to matrix test? Okay, so we say matrix test 2 multiplied by matrix test. Okay, so when we run this, that is it over there. What if we have a factor and we want to multiply the, or we want to multiply the matrix by the factor? So we could say we want to multiply 5, okay, or we want to multiply matrix test 2 by 10. Okay, and when we run, you could see that matrix test 2 has been multiplied by 10. Now take note, all these petty calculations I'm doing hasn't been stored in R's memory. Why? Because I haven't assigned them to an object. Okay, so if I want to have these, or if I want to work with these again, it means that to make things easier, I'll need to create an object to store them. I have already explained, okay, all these. Okay, good. So let's see how to transpose a matrix. Okay, now we could transpose a matrix using a transpose function. It's a simple T. Okay, so let's say I want to transpose matrix test 2. Okay, so transpose matrix test 2, and when we run, you would see that matrix test 2 initially was column wise. Okay, matrix test 2 was 1 3 5 7, but when we transpose, it has now taken a by row form, so it's 1 3 5 7 9 11 13 15 etc. All right, good. So let's move on. The next thing to do is to explore how to sum rows and columns of a matrix, or find the means of rows and columns of a matrix. Okay, so to find the sum of rows of a matrix, you're going to use the function row sum. Okay, so let's find the sum of rows in matrix test 2. So when we run this, it says that if you should sum matrix test 2, okay, let me just call matrix test 2 here so that we see. So if you should sum this row of matrix test 2, okay, you're going to get 52. If you should sum this row, you're going to get 60. If you should sum this row, you're going to get 68. And if you should sum this row, you're going to get 76. All right, now we want to sum the column. Okay, the column, we want to do a column sum of matrix test 2, so we're going to use the cosum function. So cosum the column sum function, and I want to column sum matrix test 2. Okay, so when we sum the columns, okay, it says when you sum the whole of column 1, you're going to get 16. When you sum the whole of column 2, you're going to get 48. If we sum the whole of column 3, it's 80. If we sum the whole of column 4, this is the value. All right. What if we plan on finding the means of the rows and the means of the columns? So we're going to use row means if we want to find the means of the rows. So we say row means of what? Matrix test 2. Okay, and here we have here we have the means of what? Matrix test 2. So these are the means of matrix test 2. That is the row means. Okay, so if we take this plus this plus this and we divide by 4, we get in 13. Okay, if you do the maths, 52 divided by 4, it's 13. Okay, in the same way, if we want to do that for the column means, we call column means matrix test 2, and we have that as well. All right, so now we want to move on and consider the next thing that has to do with matrix. We want to see how to create a diagonal matrix. Okay, so we could use in creating a diagonal matrix, we could use the diag function. Okay, so let me create an object called diag test. So diag test, coming up with names sometimes is difficult and it's strange. So diag test. Okay, and diag test, the object is going to contain the diag matrix. So we want a diagonal matrix of 1 2 3 4 5 6. Okay, so when we run this and we call diag test, you see that our diagonal matrix has been created. We have 1 2 3 4 5 6 in a diagonal format. All right, what if we want to find the determinant of a matrix? Let's say we want to find the determinant of matrix 2. Okay, so we'll use the det function. So det matrix 2 or matrix test 2. Okay, and it says that the determinant of matrix test 2 is negative 1.514 blah blah blah. Okay, now you should take note, I didn't create an object for this. Okay, so supposing I want to use this value here, it wouldn't be possible. Okay, it means that I would need to reproduce or type whatever I did again. But if I don't want that, then I'll have to create an object. So I'll create an object called det object. Okay, and that object is going to store the determinant. So once I call that object, okay, it just gives me the determinant straightforward. All right, now how about adding rows or removing rows and columns from a matrix? Okay, so so if I want to add a row to a particular matrix, let's say matrix test 2, let me call matrix test 2 so that we see. So this is the elements in matrix test 2. Okay, the number of rows in matrix test 2 is 4. So what if I want to add one more row to it? Okay, you're going to use the row bind function. So row bind, that is r bind. Okay, and we want to bind matrix test 2, okay, to these other elements, or we want to bind these other elements to matrix test 2. So the other elements we want to bind to matrix test 2 is 3, 80, 45, and 67. It has to be of the same length. So when we run this, you can see that now matrix test 2 has 5 rows, and at the 5th row, we have the new element, okay, fused with it. All right, so this is going to be a test you're going to conduct on your own, okay? So I have taught you how to pull out an entire row. I have taught you how to pull out an entire column. So do this. Supposing you are to pull out, or you have to take out or to remove a particular row or remove a particular column from a matrix, how are you going to do that? You could leave that function or that line of code, okay, you're going to use in the comment section for all of us to see what you did. All right, so I'm not going to do that. You do that for me. And if I want to bind to if I want to bind elements to the column, I would use the cbind. Okay, cbind matrix there's 2, and then I could bind these elements. If that is the same thing I want, I could bind them. And when I run, okay, you could see that at first matrix test 2 had 4 rows and 4 columns, but now um, it has 5 columns and 4 rows. Still take note, I haven't stored them in objects, so it is not really being stored in R's memory. Okay, good. Now, how do we determine the dimensions of a matrix? To determine the dimensions of a matrix, you need to use the function dim. Okay, so let's say I want to find the dimensions of matrix test 2. Okay, so to find the dimension of matrix test 2, I'm going to use a function called dim and matrix test 2. And it says the dimension of matrix test 2 is 4 by 4, so 4 rows, 4 columns. Okay, 4 rows, 4 columns. Now, if I want to find the number of columns of matrix test 2, I'm going to use the encol function. So number of columns of matrix test 2, and it says the number of columns is 4. And if I want to find the number of rows of matrix test 2, say n row matrix test 2, and it says the number of rows of matrix test 2 is 4. Why? Because matrix test 2 has a dimension of what? 4 by 4. Okay, all right, so I want you guys to ponder over this, try your hands, come up with new things. Okay, you could be creative. Okay, don't just practice, try to get some real life examples and work with them. Maybe you have some numbers, maybe you have a particular data, some genotypes you want to store in a matrix. You have some particular, let's say, data, okay, you want to create a matrix to store them. You could easily do this. Okay, so you could do all this in that. Now, the final thing I want to leave you with is how to convert a matrix to a data frame. Okay, so let's say we have matrix test 2. Okay, now matrix test 2, for instance, is a matrix. Now I want to convert matrix test 2 to a data frame. So I'll say matrix. I'll create an object called matrix data frame. That's the object name I'm giving to it. Okay, and I'll use the function called as.dataframe. So as.data.frame. And what do I want to make a data frame? The matrix. And what is the name of that matrix? It is matrix test 2. So the moment I run this, now matrix test 2 has been converted to a data frame. So if I call matrix data frame, you will see that we now have it as a data frame and no longer a matrix. Okay, same way, if you want to create an empty matrix and convert it to a data frame, you are going to nest the matrix into the as.data frame. Okay, it's a lot. You could do a whole lot of things. Okay, so these are just some few things I'll just add. So we have as the data frame, if you want to test if something is a vector, you could say is vector, okay, and then you put the element there, the object there, okay. So if I want to check if matrix data frame is a vector, and I say matrix data frame, and I run, it says what? False, because it's not a vector, okay, it is a data frame, okay. If you want to convert something to a vector, you could use the as dot vector, okay. In the same way, if you want to convert something to a numeric, as dot numeric, okay. Just think of it. If I want to if I want to turn an object to a character, as dot character, okay, as dot character. But in all these, you need to make sure that the object you are converting from one form to the other is stored in a new object, okay, so that the update will be stored in R's memory. Okay, so this brings us to the end of today's tutorial. I'd like you to go sit down, go through the script thoroughly. If you have questions or you have concerns, um, you could leave it in the comment section. Okay, you could leave it in the comment section and we'll address it. Thank you very much for your time and see you next time.